Hi there guys, welcome to this video memo for grade 12 physical science mid-year exam paper 2 for Elroy Academy. And I want to start by just saying that once again the evidence is clear that the students that use the online courses did about twice as good as the other students. So the online course really does work. If you have it, use it. If you don't have it, consider getting it, but it is really helpful as it did reflect in the marks. But let's continue with this question. Question 1 is the multiple choice. And sorry about that. Intermolecular forces. Multiple choice, choose the correct word or the correct option. Intermolecular forces are attractive forces between protons, atoms, molecules, substances. It's intermolecular forces. So it's forces between molecules. The first one is C. What is the name of the polymer made of the monomer? So if we made a polymer of this monomer, this monomer is ethene. So polymer from it would be polyethene. Okay, so in other words, it's B. The following reaction occurs. So this reaction occurs. Which of the following can be used to measure the rate of this reaction? So rate of reaction, depending on what the products are, can be used to measure the rate of reaction. So for example, if there's a gas, the gas will escape. So if we measure the mass of the substances involved, since the gas can escape, we can look at how as the reaction is occurring, how the mass is reducing because the gas is escaping. So that's an example. So when there's gas involved, we can measure the volume produced by the gas. It's another example. So let's have a look. Measuring the volume of the gas produced. Well, there's no gas produced. It's a solid and a salt that is dissolved in the leftover liquid. That is this liquid solution there. Okay. Observe the precipitate formed. A precipitate is when there's a solid that creates a substance at the bottom of the container. And so if that container is a glass container, the precipitate would form as a slug, for lack of a better word. So that's definitely what we can use because there's a solid being formed in a solution. So that's what we would call a precipitate. Observing the change in mass, well, there would be no change in mass because there's no gas escaping. All of the above, no, only number B. The reaction below has reached equilibrium at temperature of 50 degrees Celsius in a sealed gas syringe. Okay, so this happens. Okay, consider the following statements. Okay, first statement is an increase in the amount of H2S will favor the forward reaction and increase the Kc value. So there's going to be two things mentioned here. Which side will be favored and what will happen to the Kc value? Is it true? Eventually they are going to ask which of the above statements are correct. What changes the Kc value? Okay, the coefficient, the constant coefficient. What will change the Kc value? Only temperature. So it will increase the Kc value? No, one is immediately wrong. Doesn't matter which side is favored. So an increase in pressure will not change the Kc value. That's true. Only temperature will, and will not favor the forward or the reverse reaction. Well, let's see. If we increase the pressure, okay, it will favor the side which has the least amount of molar gas. On this side we see we have 3 moles of gas, 2 plus 1. This side we have 1 mole. So the reverse reaction is favored. As the pressure is trying to equalize, it tends to produce more of the substance that will take less space. Okay, and that would be more of the reactants in this case. So the reverse reaction is favored. So this is also not true. An increase in temperature will favor the forward reaction and increase the Kc value. Will the Kc value increase with the temperature increase? Well, it depends on which side is favored. An increase in temperature will favor the forward reaction. Now we need to go and look at the heat of the reaction. This is positive. Okay, change is always future minus initial, which means there is more energy in the forward reaction in the products than in the reactants, which means in order for this to balance, we need to add energy to the products, to the reactants. That makes this a endothermic reaction because heat is being added to the system. Okay, so if we increase the temperature, we will favor the forward reaction. To favor the forward reaction, because we're adding more reactants, so more products will produce. So if the forward reaction is favored, then the Kc value will increase, because Kc is the well, let me draw this on here so that it makes sense to us all. Okay, so Kc is the concentration of products over the concentration of reactants. Okay, so temperature is the one which would increase the one, and that increase will cause the Kc value obviously to increase. If we increase the denominator, the Kc value will decrease, but in this case, let's get back there. Okay, so the forward reaction is favored and the Kc value is increased. So number 3 is correct. Adding a catalyst will favor only the forward reaction, but not change the Kc value. Now, it's true, a catalyst won't do anything to the Kc value, but a catalyst will also not favor any side, because a catalyst favors, reduces the activated complex. The activated complex is the same for both sides. So if I reduce it for the left-hand side, I'm reducing it to the same value for the right-hand side. So there's no side that will be favored. So number 4 is also incorrect. So the only one that's true is number C. 1.5, if sodium hydroxide, concentration of sodium hydroxide is 0.1 mole per cubic decimeter, then the pH value and the concentration of OH in the sodium hydroxide solution will be, okay, now first of all, the pH of a solution with a base, so that's the first thing you need to know, is that this is a base. This is a strong base, which means that if it is dissolved, it will completely dissociate, and which means that the concentration would dissociate completely. So this OH concentration would be equal to that OH concentration, which just means the number of ions would be 10 to the power of negative 1. Okay, so it's just the same for OH because it completely dissociates. So in that case, it's either A or B. The pH value, and remember, the pH value is negative log of the concentration of H, or if you want H3O. But because it's just an H, it's actually H. I'm going to stick to that. The concentration of hydrogen atoms. Now, we don't have that concentration. We have the concentration of hydroxide. Okay? What we do know is that the concentration of hydroxide times the concentration of H must equal 10 to the power of negative 14. So if we already have 10 to the power of negative 1 here, then this one obviously has to be 10 to the power of negative 13 in order to get 10 to the power of negative 14. So if we take a negative log of that, it just gives us the exponent of that answer. It would be 13, negative times negative is positive, so pH would be 13. Another fairly straightforward way of having answer, so the answer is A. Okay, another fairly straightforward is NaOH is a base. So bases have pHs bigger than 7. So without having done the calculation, you could have known that it is 13. A diluted acid is added to a compound causing a fizz. Which of the following could not be the reactants in this reaction? So a diluted acid is added to a compound. So there's different acids. We've got hydrochloric, sulfuric, vinegar, perchloric acid, causing a fizz. Now, why is it causing a fizz? It can only cause a fizz if it produces a gas. Okay? So here you'd have to know, well, what happens, what is the product when I add an acid to, let's say, copper oxide? When you add acid to a copper oxide, let's start with this. Before I go to that one, because that's the correct answer. When I add sulfuric acid to magnesium, okay, so an acid with a metal produces a salt and hydrogen. So this would cause a fizz. Vinegar and baking soda causes a fizz. You can do the experiment yourself, because baking soda is a base. And one of the products in baking soda, or one of the products. One of the products is carbon dioxide. So that's why it causes a fizz. Perchloric acid and calcium carbonate. The moment there's a carbonate in there, an acid will produce carbon dioxide. So all three of these produce hydrogen gas, carbon dioxide. So this top one is an acid and a metal oxide. Now an acid and a metal oxide produces, well, we can go try and figure it out. So let's say you didn't have to do this. You could have done it by seeing which one plus copper oxide. Doesn't really matter whether it's copper 3 or copper 2. Let's it would be copper oxide, so it's not 2, but it doesn't matter anyways. So what would be produced? Well, one thing that would produce is water. The other one would be the salt, copper chloride. So I don't mean to do the full equation, but my point is showing that there's no gas produced here, unless maybe this was a exothermic reaction and that it got so hot that the gas started boiling. But that's obviously not the case, because one of these have to be wrong, and these definitely produce a gas. So I'll stop it there. This is question 1 out of 12 for 12 marks. It took me 13 minutes to do, with a lot of explanation and an introduction. So more than enough time to gain some time with this question, but hopefully it all makes sense to you and it was helpful. Sorry for the ums at some point, but I'm sure you could sit through that. Thanks for watching.